Good morning, everyone, and welcome to this lecture. This is lecture number 2 in communication, and in this class, we will be winding off this particular topic. The last class, we had seen the different types of communication, and we had also seen what we mean by modulation. Modulation is the process. What is modulation? Do you remember?
Which converts low signals from low frequency to high frequency.
Yes, because the signals may be of very low frequency, and if the signals are of low frequency, they cannot be transmitted. To transmit them, they must be put on certain carriers which are of high frequency, which are high frequency waves, and this process is known as modulation. Now we will move on quickly onto the types of modulation. And the first type of modulation is known as, we will be dealing with the modulation in continuous wave, and the first type of modulation that we are going to deal will be known as the amplitude modulation. Amplitude modulation, what will happen in this amplitude modulation? We are going to change the amplitude of a carrier wave in accordance with the amplitude of the frequency, the signal wave. This type of modulation is known as the amplitude modulation of the wave. Do we understand this?
Yes, sir.
So this is what we call as amplitude modulation. Now remember, in this amplitude modulation, the phase and the frequency of the carrier wave will remain unchanged. Do we understand this?
Yes, sir.
Phase will remain unchanged. Now we have a term which is known as the modulation factor. Okay, let me give you the example of this one, and let me put it here like this. What is happening in this particular, let me see which. Okay, let me put it in the form of three this graph. This was, you see, the first one is your high frequency carrier wave. You can see the frequency is very high. EC is the amplitude of this carrier wave. Do we see this?
Yes, sir.
Then we will have a message. Sometimes we call it message, sometimes we call it signal, sometimes we call it audio signal. That is the low frequency thing that we are talking about, the low frequency signal that we need to amplify. Do we see this here? EM is the amplitude of this message, or EM is the modulus, the magnitude of this signal that is need to be amplified, or the message that needs to be amplified. Do we see this?
Yes, sir.
And then you will superimpose this high frequency carrier wave onto this low frequency message or the signal, and you will have your AM wave. Do we understand this? This is how AM waves is there. This EC is here. Do we see this EC here?
Yes, sir.
Then your EM is the distance between EC and the maximum, or EC and the minimum. Do we see this diagram very clearly?
Yes, sir.
Then we have one thing which is known as E min, and one thing here which is known as E max. I would request you to draw all these things very, very carefully, because in this one thing, the entire concept is there. Do we understand this? E min, E max, EM, and EC. Do we see all these terms here? Yes or no?
Yes, sir.
I'll give you 2 minutes to draw it. And remember, this chapter is all about remembering the simple things, remembering the term. The first term that is going to come is known as modulation index. That is nothing but the change in the amplitude of the modulated signal to the original carrier wave is known as your modulation index. The modulation index is given by this concept. Do we understand what is this modulation index?
Yes, sir.
Amplitude of the carrier wave to the amplitude of the original carrier wave. Uh, do we remember what is this EM and um, what is this EM and what is this EC here? EM is the message signal and EC is the carrier signal. K times M is the factor by which it changes. K is the factor which determines the maximum change in the amplitude. Do we understand this? If K is equal to 1, and normally it is kept at 1, if K is equal to 1, then the modulation factor becomes EM by EC. Now remember the value of this EM, and you must remember it in different ways. The value of this EM is E max minus E min by 2. Do you see it here? And the value of this EC is E max plus E min by 2. If the carrier wave is modulated by several, if more than one sine wave, then the total modulation will be under root of m1 square plus m2 square plus so on. Do we understand this? You'll have to remember this definition. What is the modulation index? This is the value of modulation index, MA, and you can also write it in this fashion. If K is equal to 1, and in most cases K would be equal to 1. I'll give you 2 minutes to write it very calmly. Well, since we have come to know about the modulation index, then we will move on and see the voltage equation of an AM wave. Now, what is the voltage equation of this AM wave? We have two waves here. One is the EC, the carrier wave, and the other one is EM, the message wave, the signal wave. Do we understand this? Yes
Yes,
or no? Now this EM is actually equal to M times EC, so I can write it like this. Yes or no?
yes, sir.
Now, 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 if I have to write the value of this EM wave, I can write it as A times sine of omega C into T. Where what is this A? This A will
Maximum
be the
amplitude.
amplitude of the AM wave, and this omega c is the angular frequency. Remember, the angular frequency of this carrier, of this AM wave, is same as the carrier wave. Do we understand this?
Yes, sir.
Now this this amplitude A of the AM wave will be equal to carrier wave plus k times EM. If I take k as equal to 1, the amplitude becomes this, or the amplitude becomes equal to this. Do we understand this? So
Yes.
now my EM waves start to look like this. My EM waves start look. Remember, you will have to remember all these things. The question that is going to come, if it is going to come, if it comes in one session, it is going to be coming in all the sessions. The question is going to be pretty simple based on what we are discussing here. I hope everyone is paying attention. Yes or no?
Yes, sir.
So the EM wave, and again I will write it, EM wave can be written as EC plus EM. Remember how I am writing it. Sine omega mt times sine omega ct. Do we see this? Do we see this? Yes or no? No, yes.
Yes, sir.
I'll give you 2 minutes to note this down. You just have to note down the important facts. Here we have explained what all terms mean. I hope you understand what are the meaning of these terms. Yes or no?
Yes, sir.
You just have to note down what is the value of the amplitude. If k is 1, it is like this, then you can write the wave like this. I'll give you 2 minutes to note it down. Moving ahead, I'm again showing you. This is the final diagram of the amplitude modulated wave, and now I have shown it in a bigger way so that you all understand this. Now, remember we started by writing it like this. E is equal to the AM wave will be equal to E sine omega c into t. Yes or no? Yes or
Yes.
no? That means the omega for this wave is same as the omega of the carrier wave, because we have changed the frequency. Yes or no?
Yes, sir.
Then we have seen that this amplitude can be written in this form. Is everyone following me?
Yes, sir.
Yes or no? Then we can write the value of the amplitude, and we can see that this becomes EC plus EM sine omega t times sine omega ct. Do we understand this?
Yes, sir.
After this, it is maths. We can now write this by using trigonometry as a sum of three waves. This basically, and you have to remember this AM wave can be thought of as consisting of three waves. The first wave is having an amplitude of EC and a frequency of omega c. The next two waves are having an amplitude of MAEC by 2, amplitude of MAEC by 2, amplitude of MAEC by 2, and having frequency. The first wave is having amplitude of EC and frequency of angular frequency of omega c. The second wave, can anyone tell me what is the amplitude and frequency of the second wave?
MSEC by 2 is the amplitude.
MAEC by 2 is the amplitude. Can you tell me the angular frequency?
Omega c minus omega m.
Omega C minus omega M. Remember, very important terms I am telling you. And the third wave is
MAEC by 2.
MAEC by 2, but the angular frequency is omega C plus omega M. Do we understand this?
Yes.
And you can see we have something, the green thing is known as the top envelope, which is the maximum possible amplitude. And this blue line is the bottom envelope, which is the maximum amplitude in the negative direction. Do you see it's coming out so wonderfully? Yes or no?
Yes, sir.
What, sir? This, sir, is E min, sir. This, sir, is E max, sir. Everything beautifully drawn here. This is your EC. Do you see your EC?
Yes, sir.
And the difference between EC and E max will give you the value of EM. You have to remember those formulae. Yes or no? No, yes.
Yes, sir.
If you remember those formulae, beta, things are going to pan out very nicely. I'll give you 2 minutes to note this down. This is a simple question that will help you in understanding the various formulae. An audio signal of amplitude 1/2 the carrier amplitude is used in amplitude modulation. Can you find out the modulation index? Use the formula. I'll give you 2 minutes. Best of luck. Half is correct, my dear friends. Well done. So what is given in the question? In the question, it is given that EM, the audio signal, is half of EC. Yes or no? Yes or no?
Yes, sir.
Now I can write E ka maximum value is EC plus EM. So I can write it as 3 by 2 EC. Yes or no?
Yes, sir.
I can write E min ka value as EC minus EM. EC minus EM would be half. Yes or no? Half of EC.
Yes.
The modulation index M is given as E max minus E min divided by E max plus E min. Yes or no?
Yes, sir.
And I can write it now as putting the values, I'll get the value as half. Do we understand this? Yes or no?
Yes, sir.
Everyone understands this?
Yes, sir.
Okay, then we move on to the next heading. Still in amplitude modulated wave. Most of the question in your JEE are coming from this amplitude modulated wave. And the question that I have seen have this, they ask you the sideband frequency and bandwidth. What is the sideband frequency? We have seen that your AM wave consists of 3 waves. Yes or no?
Yes, sir.
The first wave is having a frequency of FC, carrier frequency. Yes or no?
Yes, sir.
The second wave is having a frequency or angular frequency FC minus FM. Do we remember this?
Yes, sir.
And the third one is having a frequency FC plus FM. Yes or no?
Yes, sir.
The first wave has an amplitude of EC, and the second and the third waves, they have the amplitude of MA into EC by 2. Do we see this here in the graph?
Yes, sir.
FC plus FM is known as upper sideband. FC minus FM is known as lower sideband. The distance between the two, do you see the distance between the two, the yellow one?
Yes, sir.
The distance between the two, my dear friends, is known as your is known as your is known as your bandwidth. 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 Do we understand this?
Yes, sir.
Everyone understands this.
Yes, sir.
Bandwidth. Remember these. Most of the question that you are going to see will appear from this particular section. The bandwidth. They might be asking you the bandwidth or the side and the upper and the lower bands. This is again a diagram. The other diagram has become a bit clumsy, so I am showing you this one. Do we understand this?
Yes, sir.
The distance between these two is 2 times of FM. This 2 times of FM is known as the bandwidth. I'll give you 2 minutes to note this down. Everyone has noted this down?
Yes, sir.
Now let us crack a couple of questions here based on your amplitude modulated wave. As I told you, most of the question that you're going to see will be from the amplitude modulated wave. This is a question taken from 2019 JEE Mains. An amplitude modulated circuit, the carrier wave is given by, while the modulated signal is given by the value of modulation index, and the lower sideband frequency is lower sideband frequency, lower sideband frequency. It is option D, sir, and that is the correct answer, sir. Well done, sir. Now, you must understand that modulation index M is given by the modulating signal divided by amplitude of this. You can also write it like this, yes or no?
Yes.
Uh, Here it is, the signal is 2 volt and this is 4. So you get the answer as half. So the only two options that are possible are this, yes or no?
Yes.
You have to find out the lower sideband. The lower sideband will be equal to FC minus FM, yes or no?
Yes, sir.
Now here, what is FC and what is FM? FC is 20,000 omega divided by 2 pi. So this is 10,000, yes or no?
Yes, sir.
And FM is 2000 pi divided by 2 pi. So that is 1000 pi, 1000. So your frequency becomes 9 kilohertz, and the correct answer is option D. Do we understand this, or this has gone above our head? Saying bye bye. Bye bye. I'm going bye bye. Bye bye. Bye bye. Bye bye. Do
We
we
got
understand this?
we got it.
Pakka?
Yes.
Then comes this question, my dear friends, again from the JEE of 2019. A message signal of frequency 100 megahertz and peak voltage 100 volt is used to execute amplitude modulation on a carrier wave of 300 gigahertz and peak voltage of 400 volt. The modulation index and the difference between the two sideband frequency. When I say difference, they're asking you the width, the bandwidth. You have 2 minutes to show your talents. So this is the next question. Solve it. You have a signal A cos omega t, which is transmitted using a carrier V naught sine omega naught t. You have to find out the correct signal. It is option D. I had already given you the formula to find out the value of the signal. You just write AC plus your EM and you multiply it by the sine of omega naught t. Yes or no? Here it will be equal to V naught plus EM is A cos omega t into sine omega naught t. When you add this using trigonometry, you will get this. Or you could straight away use the formula that this wave consists of three waves. Did I give you this formula?
Yes, sir.
You could have straight away used this formula and get the answer straight away. The only problem here is here both the waves were sine waves. Here one is the sine wave and other one is the cos wave, and that is why I have not used the formula directly. Everyone understands this?
Yes, sir.
These are the major questions that I have seen. The one question that I have not seen, but it may come, is regarding power in AM waves. You will have to remember all these formulae. We already know the formula of power is V square ms divided by R. Yes or no?
Yes, sir.
The carrier wave power will be given by EC square by 2R. The sideband power will be given by this formula. Total power will be given by this formula, carrier plus sidebands. Total power divided by the carrier power, the ratio will be coming like this and this. So you will have to remember all this. There is nothing I can do about it. Just note down these formulae, and if they come, you'll have to put these formulas. I'll give you a minute to note this down. Then we move on to the advantages and the disadvantages or limitation of amplitude modulation. For amplitude modulation, AM wave, AM signal, noisy, very low efficiency, small operating range, and poor audio quality. AM band, if you listen to in radio, quality is not good. But what are the advantages? It gives a noiseless reception. Here, noise that we are talking about is in the form of amplitude variation. The operating range, oh, sorry. These are the advantages of FM. Sorry. So I will just do it afterwards. Uh, these are the limitation of amplitude modulation, and how do we remove those amplitude modulation defects, that we will see in the next one. I just posted it here. I'll give you 2 minutes to note this down. We have seen the limitations of amplitude modulation. Now, how do we overcome these limitations? We overcome these limitations by frequency modulation. When a modulating signal is superimposed on a high frequency carrier wave in such a way that the amplitude is same but its frequency is varied, then it is known as your FM wave. You don't have to draw this. This is just to make you understand. This is a signal wave. This is a high frequency carrier wave. We superimpose these two, you get a FM wave. The amplitude is not changed, but the frequency is varied. Do we understand this? In that AM wave, you had seen what you had seen. See, you had the amplitude continuously varying. Did you see that?
Yes, sir.
But here in the FM wave, you can see that the amplitude remains constant. The frequency might keep on changing. Do we understand this?
Yes, sir.
I'll give you a minute to note this down. So what is frequency modulation wave? The frequency of the carrier wave is changed in according to the audio frequency. Audio quality of AM transmission is poor. We remove the amplitude variation and we make the quality very good. Do we understand this?
Yes, sir.
The overall amplitude remains same. The total transmitted power also remains same. Now the frequency is valid. There is a mean frequency FC. The deviation between the maximum and the mean, and I will show you with a diagram in the next class or on the next sheet, or between the minimum value and FC is known as your frequency deviation. Again, you will have to remember the formula. It can be written as Kf into Em by 2 pi. Kf is a constant of proportionality. This constant would be given to you in any case. I'll give you 2 minutes to note this down. Then these are the other terms. Sometimes they ask you the carrier swing. It is the total variation in frequency from the lowest to the highest level. I'll give you one question and that you will may be able to understand. The maximum difference in frequency is known as carrier swing. The modulation index is the maximum deviation to the modulation frequency. You can write it in different forms: F max minus FC, FC minus FM, doesn't matter. Then this frequency spectrum, this is the carrier frequency, and this frequency spectrum actually consists of infinite number of frequencies. The first band is FC plus or minus FM. The second band will be FC plus or minus 2 times FM. Then the third one will be FC plus or minus 3 times FM, 4 times FM, 5 times FM, and so on. Do we understand this? It consists of infinite numbers. Do we understand this?
Yes, sir.
It consists of infinite numbers, and therefore the bandwidth is 2n multiplied by FM, where n is the number of the band which we are talking about. When you put n as 1, you will get the bandwidth of this one, n is equal to 1. If you put n is equal to 2, you will get the bandwidth of this spectrum. Do we understand this?
Yes, sir.
Anyone understands this?
Yes, sir.
I'll give you a minute to note this down. Then we move on to this question. What is the modulation index of a FM carrier where the carrier swing is 200 kilohertz and the modulating signal is 10 kilohertz? How do we solve a question if it comes like this? Carrier swing is 2 times the maximum the deviation. Do we know this? We have just noted it down. So from there you can get the deviation. Deviation will be 200 divided by 2, that will be equal to 100 kilohertz. Do we understand what I have done here?
Yes, sir.
From here you can find the modulation change divided by the modulating frequency. So it will be 100 divided by 10. The modulation index would be equal to 10. Do we understand how I have done this?
Yes, sir.
I'll give you a minute to note it down. Let's move on to the next question. 100 megahertz carrier wave frequency is modulated by a 10 kilohertz signal. The maximum frequency deviation is 50. What is the modulation index? How will you find out the modulation index in this case? Modulation index is the deviation divided by modulating frequency. Do we understand this?
Yes, sir.
Can you tell me what is the answer for the modulation index here? What is the maximum deviation? It is 50 hertz, 50 kilohertz, yes or no?
Yes, sir.
And the modulating signal is 10 kilohertz, so the answer would be 5. Do we understand this?
Yes, sir.
Everyone understands this?
Yes, sir.
I'll give you a minute to note it down. With this, we come to an end of this particular chapter, communication system. We are done with communication system. At the same time, we are also done with your modern physics. I'm expecting one, at least, maybe two, and if I count chemistry as well, you can have 3 questions from this entire modern physics, starting from atomic structure to nuclear physics, atomic structure and nuclear physics, radioactivity. These are part of your chemistry as well. So if I combine all the three, I mean chemistry as well as physics, you can expect at least two, or on the higher side, 3 questions from this particular section. We are done with this. In the next class, we will do wave optics, and it's a small topic, and I will try to cover it in the next class. Take care. Have a nice day. Bye bye.
Thank you, sir.